This is section 5.3, bisectors and triangles. So when we finish, we're going to be able to identify properties of perpendicular bisectors and angle bisectors. So let's begin with our vocabulary. So the first word that we're going to talk about is concurrent. And something is said to be concurrent when three or more lines intersect at the same point. So when three or more lines intersect at the same point, they are said to be concurrent. Now, the point of concurrency is the point where these lines intersect. So that is the point where the lines intersect. Okay, now let's take a look at Theorem 5.6, Concurrency of Perpendicular Bisectors Theorem. So the perpendicular bisectors, noted by the red lines in the graph, of the sides of a triangle are concurrent at a point that is equidistant from the vertices. So this point P, they intersect. Point P is the point of concurrency. So we're talking about the perpendicular bisectors of each side of the triangle. And BP, AP, and CP are all equal. That is, they're all equidistant. They're all concurrent. Okay, so now we have another vocabulary word. So now we're going to talk about the circumcenter of the triangle. And the circumcenter of the triangle is the point of concurrency of the perpendicular bisectors of a triangle. So point P is the circumcenter of the triangle. And notice we have the same graph that we had on the other page. Notice that the vertices of the triangle are all on the circumference of the circle. P, the circumcenter of the triangle, is the midpoint of the circle. So one thing that is interesting is that the circumcenter of a triangle can be inside, on, or outside of a triangle. So in an acute triangle, in this particular acute triangle, it's on the inside. And in this right triangle, it falls on the hypotenuse. And in this obtuse triangle, it's outside of the triangle altogether. So now we're going to look at problem 1. And in this problem, they want us to find the circumcenter of the triangle. So they gave us the coordinates. So the vertices are the point 0, 6, 0, 0, and 4, 0. So I am going to plot those points. So 0, 0 is at the origin. 0, 6 is right here. And 4, 0 is, let's see, 1, 2, 3, 4, 0. So now I'm going to take a second and I'm going to get my straight edge and connect those. Okay, so I have my triangle. So it's a right triangle. I know that. Now what is the circumcenter? Okay, so if you look up here, we just did this earlier, the circumcenter of the triangle is the point of congruency of the perpendicular bisectors of the triangle. So we need to find the perpendicular bisectors. And this triangle is going to be super easy to do. which ones are easiest? So if you said it was easier to find the perpendicular bisector of segment PO and OS, you would be correct, because these are on my axis, my x-axis and my y-axis. So I can know, let's see, so this is point 0.06. So this is going to be 3 up. And let's see, S is 0.40. So I know the midpoint on OS is at 2. Now, do you remember how to write the equation of this line? So for this one, this is my perpendicular bisector. What's the equation of this line? It crosses the y-axis. So it's at y equals 3. And let's take a look at this one. So this would be the perpendicular bisector. And what's the equation of this line? It's x equals 2. So where do these 2 points intersect? They intersect at the point 2, 3. And that is the coordinate of the circumcenter of this triangle. So remember that the circumcenter of the triangle, if I were to draw a circle, the circle would hit all 3 vertices, and the center of the circle would be at the point 2, 3. So what does that tell you about the vertices? That they're all the same distance from the circumcenter. So now let's look at another problem. So a town planner wants to locate a new fire station equidistant from the elementary school, the middle school, and the high school. So where should he locate the station? So looking at this, first thing I'm going to do is I'm going to pause and I'm going to connect all of these points and form a triangle. So I've made a rough approximation of getting these connected. So the next thing I need to do is I need to draw a perpendicular bisector. So I'm going to do mine on segment HE and on HM. Now the important thing to remember is it does not matter which 2 sides you choose, or even if you do all 3, because the perpendicular bisectors of each side will have they're concurrent, so there will be a single point of concurrency. So you can only do 2, and that's fine, because if you do 3, they're all going to meet up in the same place. So I am going to do that now. So when I drew my 2 perpendicular bisectors, I see that they intersect right around here, and we will call this point P. So this point would be a point that was equidistant from all 3 schools. So now we're going to take a look at Theorem 5.7, concurrency of angle bisectors. So the bisectors of the angles of a triangle, noted in red, are concurrent to a point that is equidistant from the sides of the triangle. So notice that point P is equidistant from X, which is equidistant from Y, and equidistant from Z. So another way to say that is PX is equal to PY, which is equal to PZ. Which leads us to another vocabulary word, the incenter of the triangle. So the point of concurrency of the angle bisectors of a triangle is called the incenter. So the point of concurrency of the angle bisectors of a triangle is the incenter of a triangle. In this diagram, x, y, and z are equidistant from point P, which is the incenter of triangle ABC, and is the center of the circle that is inscribed in the triangle. Okay, so there's a lot of words going on here. So you might need to pause and kind of look at the diagram and think about it, or rewatch the part that's giving you trouble. Okay, so now let's take a look at problem 3. We are going to use our information about the incenter of a triangle to answer the question. So they're looking for the how long is GD. So first let's identify what we have. So if I look at all 3 of my vertices, GA bisects angle A, GB bisects angle B, and CG bisects angle C. So those are my 3 angle bisectors. Now where do those points meet? They meet right here at G. And what is point G called? G is called my incenter of the triangle. It's the point of concurrency of the angle bisectors. So what do I know about GE and GF? What do I know about these 2 sections? Oh, well that's perpendicular from the point of concurrency of the angle bisectors. So I know that these are equal. So I can use that information to solve and find out what x is, and also find out the length. So 2x minus 7 is equal to x plus 4. I'm going to subtract x from both sides. So I get x. Oh, let me go ahead and add 7 to both sides also. So I get x is equal to 4 plus 7 is equal to 11. So I know that my x value is 11. So the easiest equation for me, I'm going to choose to use x plus 4. So GF is equal to x plus 4. GF is equal to 11 plus 4. So that is equal to 15. And I know that they are all equal or congruent. So I know that GD is equal to 15 as well.